We're at the bottom of page 2 now in 9.1 on the notes, and the instructions are just out of view here, but you should have them on the page in front of you. And I also read them at the back of at the end of the last video, at the top of page 2. And it says graph each equation, so we're going to take this and draw the picture that it creates. If you haven't caught on to what's going on here, is that every equation in algebra, when it has two variables, an x and a y, creates a picture on this coordinate plane. All the solutions that work in this equation, all pairs of x's and y's that work, connect to make a picture. And we did a lot of lines, then we did systems where there were two lines on the same graph, and now we're looking at what's the picture going to look like when you have radicals involved. So the instructions say to begin by filling in the table and finding 5 solutions of the equation. So what you don't see on the notes here is what we're about to draw in, and that is the table. So we're going to pick some values for x. This should sound familiar. This is kind of our beginning graphing stages. Whenever we look at a new type of equation, we start by picking some points. And then we're going to plug it into the equation so that we can get our y values, because our goal is to get a pair of x, y points that we can then plot on the graph. Okay, and what we'll do in the middle then is plug that into it. Y equals our x plus 2. So we'll take our x and plug it in, get our y value out. Okay, so let's pick some points here. Let's do some negatives, do some positives. When we do -2, let's try that. This is an opportunity for you to kind of engage your brain, because when we did lines, it was very easy. You could just pick a couple negatives, a 0, a couple positives. If there were fractions involved or decimals, some of you became very strategic in how you picked your x's, so it would make the computations easier. We definitely want to do that for ourselves here as well. Doesn't mean that you can't put anything in, but to kind of see what's happening here and to get practice with roots, you want to strategically and pick those x's very carefully. So pick your x's carefully. You'll see what I mean here in a minute. One of the reasons is because we don't want any negatives under the radical, because we can't figure that out. There's no real number for that. The other thing is we'd like to be able to have nice numbers that we can figure out the square roots of, especially without a calculator. You'll have a calculator for the exam, but it's just easier graphing wise if we can get nice numbers out of this. Okay? So when we put our -2 in, we have our radical, and then we have our x plus our 2. And so we're going to put -2 in. -2 plus 2 under the radical is 0. And square root of 0 is just 0. What times itself gives you 0? 0. So our point that we've created is -2, 0. So we go over here, -2, 0. That's our first point on the graph. The next one that we'll pick is -1. So I'm putting -1 into our equation here. Instead of x, it'll be -1. -1 plus 2 gives you a +1, and we know the square root of 1. That's going to be an answer of 1. So our point that we've created here is -1, +1. So that would be to the left 1, up 1. There's our second point on the graph. -1, +1. For my third point, I'm going to pick, let's say I was continuing on here, I'm going to pick 0, and what that would look like, again, is I plug in for x, I'm going to put in 0, add 2, I'm plugging into the original equation, 0 plus 2 is 2, radical 2, this is why I want to carefully choose. I can just happily kind of pick my -2, -1, 0, 1, and 2, but all of a sudden I've got funky numbers. You'd have to go to your calculator for this one, end up with 1.71. So you have a point of 0, 1.71. Well, I'm not even going to attempt to see what that point would be here. I'm going to see if I can now strategically pick some numbers that are going to work out nicer for me. So I'm going to go for, Let's see. What do I know? I know radical 0, I know radical 1. The next one I know is radical 4. So how can I get 4 underneath there? Well, if I add 2. So let's go ahead and put a 2 in for x. So I put in 2. That gives me 2 plus 2. That gives me radical 4. I know radical 4, square root of 4. That's just positive 2. So my point here is 2, 2. So 1, 2, 1, 2. And when we connect the dots later, we'll see if we can estimate pretty closely where that 0, 1.71, it's right up there. But we'll put that pink dot in later to make it match. The next thing I know square root of 4. The next perfect square is going to be square root of 9. So I want to add something to 2 that will give me 9. So my next strategic point that I'm going to pick is 7. So 7 plus 2 is radical 9, and the square root of 9 we know to be 3. So the point here, and I kind of shifted my points down a little bit, so let's get myself another spot here. 7, 3. I'm going to end up using this one, or this one actually. Okay, so the point 7, 3, here's 5, 6, 7, what, 1, 2, 3. Okay, not exactly a straight line if you're watching here and seeing what's going on. So let's try the next one. Again, what do I want? Well, the next one I know after radical 9 is radical 16. So what can I add to 2 to get me 16? I can put in a 14. So 14 plus 2 gives me radical 16. That gives me 4. So 14, 4 is my point. 10, we're way out here. Probably up here somewhere would be about my estimate. That's the point 14, 4. So let's fill in here. We've got the point 2, 2. We had the point 7, 3. Way over here we have the point 14, 4. And then when you connect these, you notice it's not a straight line. In fact, it curves. And some of you might be thinking, you know, that kind of feels like it's similar to the graphs we did when we had to graph some of the exponents, some of the quadratics. Indeed. And notice here's where that 0, approximately 1.71, lands. Square root of 2 is not a rational number, so it has a decimal that repeats. It does not repeat. It goes on and on and on forever without repeating. So it's a little bit harder to graph. That's why we want some, you know, you have to round it, approximate it, so that's why we want the strategic picks for our x value. Let's look over here at number 30, where it says describe one similarity and one difference between your graph in exercise 28 and the graph of y equals radical x shown in the figure 9.2. It got cut off down here, but we're showing this one. So what do we notice that's similar? Well, the shape is similar. What else is similar? It doesn't dip below. There's no negative answers. So the shape is similar. There's no negative y values. They're all positive results here. What's different? I guess we only had to do one similarity, so that's one similarity. What's different on this one? Well, over here, the starting point, so to speak, is 0, 0. And then over here, the starting point is negative 2, 0. So they have different starting points. You might say, well, wait a minute. Didn't we pick those numbers? How do we know that's the true starting point? Well, as soon as you go past that negative 2, as soon as you put in anything to the left of negative 2, you're going to get a negative under the square root, and then it's no longer a real number because you're taking the square root of a negative. So negative 2 is essentially the starting point here. That's as far left as this picture will go in terms of real numbers. But then it can go on forever. You can continue putting bigger and bigger and bigger numbers, and it will just gradually and gradually and gradually continue to grow here. In this case, the graph of y equals radical x, notice there's nothing happening on the inside of the radical, so the lowest we can go is 0, because as soon as you go to the left of 0, you're putting negatives under the radical. No real number can do that. So that's a good exercise, is to kind of compare the different graphs of the different equations that we're looking at. Radical x plus 2 and radical x. Or square root, because there's no number indicated in the index, so it's understood to be the square root, or an index of 2. So take a moment and kind of talk through what you've seen here, tell somebody, get your notes copied, bring your questions to class, and then I'd like you to try this one. Use a calculator to approximate each expression, round to 3 decimal places. So you will get your calculator on the test. I want you to know how to use your calculator when you're dealing with radicals. So you'll need to find the radical sign. Some calculators have more than one radical sign. Choose the one that doesn't have the index, doesn't have a letter here, an x or a y in the index. And you'll need to kind of experiment with how your calculator understands stuff. Try typing in -7 plus radical 839 divided by 5, or do you need to get parentheses around it? So good experiment to know how you can communicate to your calculator to get the right answer. Pause, and when you come back to the video, we'll reveal the answer. What you should get when you put this into your calculator, if you put it incorrectly, because remember you have to get the calculator to understand what you mean in terms of how it's set up in order of operations, you should get 4.393. If you're not getting this value, if you're getting something different, radically different, pardon the pun, I have to use that several times in Chapter 9. But if you're getting something different from 4.393, go back and look how you're inputting it. It may mean that your calculator needs you to tell it to put parentheses around this top part, so it does that completely before it divides by 5. And that's what the fraction bar means, is division.